Hello, everyone. Welcome to another episode on realistic projects. So, today we have something beautiful to discuss. However, let's give a quick recap of what we discussed so far. So, this is our second episode in May, and the first episode we talked about the important thing to know about your foundation. So, what are some of these important things that we talked about? The most important one that I remember vividly has to be the soil testing. However, I want you to also realize that aside from soil testing, there's a whole lot of things you can learn. And how do you get to learn this? By just going to your YouTube to check realistic projects and also on Instagram, realistic project. My name remains Favor O'Rourke, and I'm the moderator of these beautiful episodes. So, and with me, I have the managing director of Realistic Projects, Mr. Adebayo Giwa. How are you, sir?
I'm doing fine. Thanks for having me.
Yeah. So today we have something beautiful. Well, we always have something beautiful to discuss. Well, before we go into that, what's the importance of this sessions? What are the importance of this episode? Is to educate and also to bring to limelight everything you need to know about building content. Today we're going to be talking about why your building cracks. I mean, you can just pass through a particular house and then you're seeing a particular building splitting in between already, and you go, why is this cracking? Is it from the plastering? But personally, for me, I used to think why buildings used to crack is from thunderstorm. I used to think once the lightning do just give that shape, because most of those cracks don't go straight. Some of them are like zigzag. So I'm always in between. Maybe it's the lightning, maybe it's the thunderstorm. So I am here with Mr. Adebayo Giwa, who is the managing director of Realistic Project. So enlighten not just you alone, even me. Is it the thunderstorm or is it the lightning that causes all of these cracks? So let's hear from you, sir.
Okay, thank you very much. Today we are talking about building cracks, and there are a lot of reasons why building cracks can occur on a building. One, which is one of the major one, if there is a structural failure.
Okay.
The other one, if there is a failure on the block work, and is more about the tampering of the block work. And the other one is the plastering, right?
Yeah.
Which is the common one that everybody try to lie about. Once they see the sign, people first talk about, oh, it's the plastering. So we are going to be dwelling more of the major issues that caused it more than just the surface of talking about the plastering. Yeah.
Okay. So from what you've just mentioned now, let's dive right into the root causes of these cracks. So first of all, let's start with what are cracks in the first place? Because some people can believe that it is not crack, it is split. So let's and some people can think it's the other crack. So let's give like a specific definition of what this crack.
Okay, in a simple term, crack is when a part of the building is kind of deviating from the other parts. So if you have something together and one part is taken away from the other part on the same member, so you can see it on columns, you can see it on walls, you can see it on beams, you can see it on slabs, on different member of the building. So that is what crack is all about in the building.
Oh wow. So now let's go into the major cause. Let's start from the primary cause of these cracks. What are some of the primary causes of the cracks?
Okay, I will start from the major one, which is the structural crack.
Okay.
Now, it can be from each level. Sometimes some crack can be that maybe at the top level of the building, there's a particular beam. Maybe if you have a building of 10 suspended floors, maybe at the seventh or eighth floor, there is a failure of a beam or a slab, and on the seventh floor, it means it carries more 3 slabs.
Yeah.
So if cracks is observed from those other slabs at the top, it's going to be traced downward. Wherever you say a crack, it is something carrying it downward that is not carrying it properly, that is failing. So it's going to be traced downward to where the issue is. If there is a particular beam or column or slab that is failing, that is leading to the crack of other ones, so that is where that is going to be fixed. All right. So that is still getting like a minimal structural failure. It's major, right? But it's still, but when it's now going down to the foundation level, if the structural crack is now from a foundation failure, that is a big issue to address. It means a lot of things is wrong with the foundation, a lot of things is wrong with the calculation of the soil bearing capacity and the load bearing, the load of the building itself. So, and that crack can occur from differential settlements of the foundation. That is, if one part is settling more than the others, or one part want to settle, the other part don't want to settle. So it means if we have a level like this part want to go down, this one is saying I'm not going. It means there will be a departure. So that departure is where we'll have that crack, and it transfers from the foundation up. So if that issue occur, is a major issue. Now, which one is the other part, right? The other part, which I will mention before mentioning plastering, is the block work. Now, if you design a frame structure, if you build a structure as a frame structure, it means the column, it means the block itself, right, is not carrying a load, right? So most cracks that happens on the wall, if there is no structural issue, right? If there's no structural issue from the beam, from the column, is due to tampering of the wall. What do I mean by that? In the process of installing service pipes, plumbing pipes, electrical pipes, especially electrical pipes, you know, all these conduit pipe that they want to install the pipes inside the wall, they will need to break the wall. So they don't finish it well properly. Some of them just use ordinary cement mixture that is not pure enough. They'll put it on it, they scrape it, they paint it. So without, even before leaving that site, before handing over that project, you start seeing cracks in those places.
Wow.
So when people now get confused, when they see a block work, a wall that is neat, the beam is not fractured, nothing with the slab, and the crack of such tampered wall is always so obvious. It's always so obvious than what you call a plaster crack, right? So when they now sit down, they feel like, why is this one so obvious? Why is it? And you see, because pipes most times is either it's coming from the ground up, or from the center, or from the up down. I mean the pipe work. So when you now see the crack and you trace it, you see it going up, you will be afraid that, why so much crack going up? I hope there is no slab failure, there's no structural. But most times it's not. You just have to trace before you feel alarmed. You have to trace that, is there a pipe work, is there a service pipe passing through that place? So if it's passing through, it's most likely going to be that issue. So that's for wall crack. Now, when we now go to the plastering, which is the one many people just try to use to cover up. Yes, when the nature of the sand is not okay, we call it plaster sand. When the nature of the sand is not okay, you see a lot of cracks. When the mixed ratio is not okay, you see a lot of cracks. And when it is not properly laid by the bricklayer during proper finishing and all that, you see a lot of cracks. But plastering cracks are always tiny, tiny cracks. They are always tiny. They are not. So if you notice something very tiny, you just have to watch it over time. Just within the period of the plastering, it will go. And if it still persists, the finishing of doing the screeding of your building will cover it up. Then final painting will cover it up. But which ones cannot be covered up? If a tampered wall due to service pipe installations are not properly addressed, you do a lot of screeding, a lot of painting, and you'll still be noticing it.
Wow.
Right? And that's not a structural failure. But the big elephant in the room is if there's a structural failure. All right. So that one, there's no cover up. You have to fix the roots of that structural failure. Yeah.
From what you mentioned, I was able to pick out two major things. Now let's trace it back to our last episode, foundation level. So is there a way that the foundation can affect the crack? So I don't know if that is where the uneven settlement, maybe that is where it comes in. Maybe there's a part of the foundation that's already sinking, and then the other part of the foundation that is still standing. Can all of these things attribute to having cracks in the house? And how should we link cracks and foundation together?
Yes, it plays the major role. It plays a major role because if there's a differential settlement, it means one part is sinking, the other part is not. So the other part that is sinking will want to detach from the one that is not because it's carrying some load also. And remember that if the part that wants to sink is like 40%, it means 40% of the whole load of the building. So everything on it, on that part that want to sink, at the part of the foundation, we want to depart. So from even if you have 20-story building, at that part that wants to depart with the foundation, the part of the foundation that is sinking, that is failing, will want to go down with everything on it. So that's why it's going to affect every other thing. If a failure happens to the foundation, it's going to affect anything on it. So it is a major role player when it comes to building crack.
Okay.
Yeah.
So when I started this episode, I cited an example. I don't know if it is a myth or it is true about lightning and thunderstorm causing cracks on the wall. Like, does it happen? There's a myth that says, oh, when you stay against the wall. The first one I heard of when I was little was if you rest on the wall that has a crack and there's lightning, the lightning wants to pass through the crack, but you as an human being that you're standing there, you're already blocking it. So there's a possibility that the lightning can strike you together with the lightning.
Okay. For my studies so far, I've not heard of that, and I would say
Okay.
that is not true. Does lightning affect the building? Yes. How does
Okay.
it? It's more of the electrical appliances that it affects. So if you don't do the earthing of your building, I know there will be an episode that will be discussing this better, right? So if you don't do the earthing of your building and have thunder arrestor for your building, if there is a lightning, TVs, appliances can get,
Blown
burnt,
off. Wow.
blown off, like electrical reactions can happen, and you just see that your TV is burnt, many things in the building is burnt. So it affects the electrical aspects of the building more than, so, when there's lightning, there is wind.
Yeah.
And when we are talking about foundation, we discussed about in our last episode, we discussed about different types of load. We discussed about dead load, live load, and wind load.
Yeah.
So what we can really attribute to the lightning that you spoke about is that, okay, when there's lightning, most time there's wind, and it comes with rainstorm and all that. So does wind that comes in that scenario affects the building? Yes.
Okay.
If the building is not structurally stable, okay, an example is when there is heavy rainstorm and there's heavy wind, you see that some roofs that are not properly done well, the wind opens the roof and take it elsewhere.
To another compound.
All right. And roof is a structural member to consider in the building too, because it protects the building. Is a very important member to consider in the building. So talking about lightning, partially no, right?
Yeah.
Now talking about the winds that comes with it, yes. If the building is not structurally stable, it can affect, the building. It can attack the building. All right.
Okay.
Wind load is something that is very important to consider in your building.
Still talking about the root causes. Now, are there instances where, for people that don't have, some basic tools to hang their bags on the wall, then they resort to using nail and hammer to put hole on the wall to be able to hang their bags, to hang your cap, to hang all of those things in the room. So can things like that necessarily lead to crack on the wall? Like especially if the wall is not really strong. So, but aside from that, can it lead to like a major damage in the house?
Okay, we're talking about the wall itself,
Yes.
taking it out of the main structural assembly of the building.
Okay.
Nailing things on the wall can affect the structural stability of the wall itself, not really the entire building,
Okay.
not really the structural. So the mode of which you do it, yes, can affect it. If you do it properly, it will have limited effect. But if you do it in a rough way, it's not properly handled, it can, and it can lead to crack. But if you have a very strong wall, you use a proper block, proper plastering, the effect is going to be limited. So the effect, whether you have a weak wall or not, is limited to how much it can really affect the entire structure of the building.
Oh, wow. So from there, I want us to move into the impact of poor workmanship and materials. Now, you've mentioned about structural failure and you've mentioned about plastering failure. So, and you mentioned that structural cracks are the ones that should not even be overlooked at all. Now, how do we measure up the fact that the craftsmanship, the workmanship, the person handling this project is not doing a bad job? The person is doing a very good job at maybe the mixing ratio, the type of sand it gets, the soil testing, everything revolving around that.
Okay. Why the term called building construction is because a lot of things are assembled together.
Okay.
All right. If you want to build now, if you want to build 1 story, 2 story, 3 story, and all that, you cannot just carry it and dump it. Even if it's precast, it is still
Yeah.
assembled somewhere to now bring it down.
Okay.
Right. So it's a combination of a lot of materials.
Okay.
It's a combination, it's a science of a lot of members, right? So materials and how it is being handled plays a major part of what we are discussing about. The quality of the materials you are using, talking about, if we are talking about structural member of a building now, if we talk about whether the foundation, the column, or the slab, we are talking about concrete. Concrete is an assembly of different members. We are talking about the cement, we are talking about the sharp sand, we are talking about the granite. So we call them aggregates, fine aggregates and coarse aggregates. And we are talking about water.
Okay.
As simple as water, water is not simple when we are talking about concrete. You have to use a pure water, right? A water that is clean enough, that is healthy to drink. You don't use salty water, you don't use anyhow water to build. So if all the other members of the concrete member is good,
Yeah.
and you are using a bad water, you have spoiled the strength of your concrete.
What of rainwater?
It's not good enough.
Wow. I think
Yes.
I'm just hearing this for the first
Yeah,
time.
it's not good enough. It's not that bad, but it's not good enough. You have to use a good water to to do your this thing. That's then even the condition at which you are mixing the concrete. If you are mixing the concrete where the weather is so hot, you have to put some measures in your mixing to get the strength that you need to get. That's another thing. Water should not. So all the cement you are using, you are checking the grade. The grade that is specified for that thing to be, you have to do whatever it takes, whatever mixing, whatever condition that you have to be to meet that grade. All right, for you to have the stability and the strength it requires to do what you need to do. So now it now boils down to who is your contractor, who is your builder, making sure that all these conditions are being met.
Yeah.
Right? So it is the builder that will determine how well the artisan is also going to do their work. The proper instruction, the proper monitoring and supervision given to them will determine how well they will meet all these conditions. So, I spoke about concrete now. When it gets to form work of doing your structural member, there are many things to consider too, right? When it gets to the reinforcement, there are many things to consider too. And while talking about foundation in our last session, in our last episode, we spoke about a lot of conditions, that comes around foundation. So all members, because they are assembly of different things,
Okay.
right? There are procedures to follow. For example, if you are cooking, there are some things that you need to start cooking with. There are some things that you need to end cooking with.
Yeah.
Right?
Yeah.
There are some times that you don't put some ingredient at the beginning of cooking.
True.
It's the major thing that you're cooking that you're putting there. There are some things that you now put at the middle. There are some that you put at the last end. So while constructing too, it's not just about mixing the concrete. There are things we consider before. There are things we consider middle. There are things we consider at the end. An example is that aside considering the mixing ratio and the temperature at which we are mixing at that moment, while pouring the concrete, there are things we consider. We pour batch by batch and we vibrate batch by batch.
Okay. When you say vibrate, is it that stuff that rolls?
The stuff that roll is the
Yes.
mixer. That one is the mixing.
Okay.
There's something called poker that we use when we are pouring the concrete. By the time we pour to a particular batch, depending on the height of the structural member or the column that we are doing, when we pour to a particular level, we put the poker, we vibrate to remove honeycomb to make sure that all the members that we mix together, the concrete, the cement, granite, and everything, connects together properly.
Okay, let's go back to the word concrete. Now, growing up and even up till now, I used to understand that the word concrete is like a solid ground.
Okay.
Like, all those already mixed. Let me use the flooring of a kitchen that does not need tiles. Maybe they would just want to do it very smooth, or the flooring of a soakaway, the way they cover it. So that's my own definition of concrete.
Okay.
Now, is it the same definition that applies to the word concrete that you're using here?
Yes, you are correct. Those are concrete, but they are now of different grades different level, different purpose.
Okay.
The one you want to do put on just a floor now
Yeah.
is different from where you want to have a suspended thing. For example, now the concrete that you have at the top of your kitchen where you don't want to have tiles, that just the concrete will have reinforcement because you need to have some things under it. It's now suspended.
Oh.
So the factors that will be considered in that type of concrete is different from the one that will just be on the floor.
Oh, wow.
That is not suspended.
And the reinforcement is like something that holds it up.
Yes, it's something that holds it up, right?
Oh, wow.
So those are the factors around that. Now, going back to the process of the concrete I'm saying earlier on.
Yeah.
So there's the process of mixing,
Okay.
right? There's the process of while pouring it. So that's like the middle process. Now, after pouring it, there's the last process of curing it. Curing is that after it has been poured, it has formed its shape, we strike out the formwork. Then we have to make sure that it's not dehydrated, it's being watered. So the process of watering it, making sure that the water inside of it is not coming out,
Okay.
right? Or adding more to the one that is coming out is the process of curing for it to gain more strength. So sometimes we sack it. When we sack it, it does not allow the water inside of it to evaporate easily. Sometimes we use a kind of nylon around it,
Okay.
or we water it every day
Oh.
for an average of 7 days. So watering it, so a concrete that is being done and not cured, right, will not be as strong as the one that is done and properly cured. So all those things contribute to, are you going to have a building crack in the future on your building or not? Right. So now look at the process. Following all the process that is required to mix, following all the process that is required to pour the concrete, following all the process that is required to cure the concrete. So if you follow all this process properly, you are going to have a good structural member, and you are likely not going to have a crack.
Okay. So still on the workmanship theme, what are some of the mistakes? What are some costly mistakes that people in that craft make that they don't eventually figure out that this was the mistake I made, maybe until years later, so that those coming up now, the developers coming up now would understand that, oh, moving forward, I should not make this kind of mistake so that I can achieve this.
Okay. There's nothing we'll be talking about building that will not make mention of the professionals.
Okay.
Okay. So following the instructions and recommendations of build professionals saves an answer all.
Yeah.
Now, to now point out some, when the architect design, the structural engineer design, MEP and all of them designs, the professional that undo doing all the works is a builder.
Okay.
So the builder have something called building methodology. So how to make sure that everything that is being designed is being done how it's supposed to be done. The builder puts all these informations together to implement on site, right? So now there's something called building methodology, how you tend to build all these things. So if all those steps are being followed,
Yeah.
there won't be issues. Now, I spoke about concrete earlier on.
Yeah.
Their process of mixing, right? If the process is being followed, there won't be issues. So those are the common mistakes. There is a lot of mistakes of artisans not mixing properly, not mixing to the mix ratio that is supposed to be, not mixing with under proper or regulated condition.
Okay.
Right? So those are the common mistakes. When it comes to pouring, not pouring properly, some will pour before they will even vibrate, they have poured the whole concrete to the top of the column. So when you are now saying you are now vibrating the column, you are only vibrating the upper part. At the bottom, you have issues there, right? So not mixing properly are common issues. Now, not curing your concrete properly are common issues. Some, once they are done with the concreting, they strike the formwork, they go, right? They just move to the next floor. Even if they are moving to the next floor, they are not still doing the process required for it to be properly killed, right?
Yeah.
So now, when we talk about the same process of doing things properly happens with column, beam, foundation, all the concrete members of the building. Meanwhile, when we are talking about building, it's just that concrete is more common. There are other structural members when we are talking about steel beams, There are buildings that can be done with steels. Instead of the concrete column, there are steel columns, steel stanchions, H-beam, and all the likes that. So there will be an episode that will be talking about steel structures, right? But the common ones, right, which
Yeah.
is readily available and there is more, concentration on using them is still the concrete structural structures, right?
So in one of the mistakes that you mentioned, you talked about the mixed ratio. Now, my question is, the mixed ratio, does it differ in different load distribution? When I say different load distribution, I mean if I'm trying to like continue the dining hall, the mixed ratio I will use to mix my cement, my granite and everything, will it differ from when I want to do for the toilets, for the kitchen, for the generator house, for the parlor? Does the mixed ratio, does it tally in that kind of manner?
Okay, the answer is that there are different mix ratio for different purpose.
Okay.
All right.
Yeah.
So when we are doing some things, there are some concrete members that are not suspended
Yeah.
and they are not reinforced concrete. The grade for that ones are different. We have grade 30, grade 25, grade 20, and thereabouts. So those grades determine the mix ratio. The grade talks about the strength we want to achieve for that concrete. All right. So for columns, there can be different mix ratio. For foundation, there can be different mix ratio. For the suspended slab, for the beam, there can be different mix ratio based on what the structural engineer want to achieve. All right. For different parts of the building, there can be. So and I want to one of the common mistakes that we need to identify out is that a lot of people just there's one common mix ratio.
Okay.
Is 1:4. So 1:4, some people once they want to mix a suspended slab, a column, this and that, they just go for 1:4.
Okay.
So, and 1:4 is not bad, but it does not work for every structural member. It does not work for every structural details. So there are cases whereby you use 1:4. There are cases whereby you use other mixed ratio.
Okay.
Yes, there is 1.5, 3. That's another grade. There are other mixed ratios, right?
Yeah.
And even after doing your mixed ratio that is calculated to give you the grade, sometimes you do that mixed ratio, you still test the strength that you're supposed to get from that concrete and you still not get it.
Wow.
So it means that it's part of the common mistake that we're not talking about that is
Okay.
coming out. It means that the fact that you mix and you mix a particular grade that is being recommended does not mean you are free. You still need to test the result. We call it cube test. So the fact that you mix your concrete according to the mix ratio for the grade you want to achieve does not mean you will get the strength you need automatically. So you need to still test that. You take a cube test. So the mix ratio, the concrete that you are pouring, you take some samples, you take it to the lab for test. There is crush test and other type of test. So when you do that test, it will tell you the strength that column, the strength you are able to achieve with that column.
Oh.
So it also helps your structural engineers to know that, okay, I've achieved this strength. If you are not able to achieve that strength, we call it per kilonewton. If you are not able to achieve that strength, maybe you are supposed to get 24, 25 kilonewton and you didn't get that. So your structural engineer will be able to adjust the next structural member.
Okay.
So that because it has known that, okay, this column achieved this particular strength. This is the strength. If I need a particular strength grade and I didn't get it, I get something a bit low. The structural engineer will be able to know what to do next. And if it's too low, it means we are going to take that structural member down and recast another one. It's better. So if it happens that maybe you mix and maybe due to some conditions and all that, and the concrete did not meet the grade, the strength is supposed to meet.
Yeah.
The best thing is to break it on site and do another one. It's far better than now having cracks in the future. Yeah.
There's a situation that I used to see. There are instances I do see, and I think talking about cracks now, I can also bring it up. Now there are instances where you'd be in the house and then maybe you've gone for a while, you come back, you see that the space between the window and the wall, there's hole already, they're already cracking, they're already moving. Then the same thing for the doors also. You're trying to jam the door, you just notice that they are contrasting already. Now I learned that there's something called expansion and contraction. That's
Yes.
like the natural movement of buildings. Is it that the buildings are breathing and then they are getting fat, or there are some days that they go on weight loss, then they now lose weight?
Okay. Like I told you earlier that building is an assembly of many materials,
Okay.
right? So, and those things tends to expand and contract.
Yeah.
So, which have been considered while building, right? So, when there is heat, when the weather is hot, there is probability of expansion. Things get warmer, they feel lighter, they want to expand.
Oh.
And then when the temperature comes down, right, they contract back to their states. All right. So those things happens. Now, when it happens in a building, now it doesn't matter because you leave the house for a long time or not. It can
Okay.
happen even if you don't, right? So
Yeah.
when they happen, most times it is still the other fittings that you have in the building that are having that contraction, that are having the obvious ones. Yes, the main building too do, but it's not really obvious. The ones that have the obvious is when you have the space, it's most likely your window material itself
Yeah.
that is expanding and contracting, and later on is not going back to its original state.
Okay.
And you see that line. It happens with door even more because door is timber,
Yes.
and timber likely have that issue. And the one of timber, even at times from experience, is not really because it's not majorly because of the contraction and attraction. It's because timber, wood itself, because of maybe high demand and rush to buy, some wood are not seasoned. When we talk about concrete, we talk about curing.
Yeah.
Now, when we are talking about wood, its own finishing to maturity to be able to use properly, we call it seasoning,
Okay.
right? So that one is about when, if you are familiar on the Thomberland Bridge, when Makoko is still very much there, you see a time that there will be a clog of woods on that river,
Okay.
right? So what they are doing now there is they are seasoning it,
Oh
right?
wow.
So it attracts all kind of chemical reactions and some moistures in the wood itself. So what you see there is that the one at the surface faces the sun,
Okay.
it dries off. So they turn it back. Another one faces the sun, it dries off. So it is the moisture content inside the wood, not the external one. The moisture content that, woods also grow, have moisture and other things that makes it alive, right?
Okay.
So when it's now cut off, all those chemical reaction and all that is still in the wood.
Wow.
So there have to be a way for it to come out, for the wood to now be stable. If it doesn't come out and you go ahead to use the wood, which is the common errors that happens.
Yeah.
So it's not properly seasoned enough, it's not dry enough for it to be used. So when you now go ahead to use it, when it's not matured, right? So in the span of 6 months, a year or thereabouts, you see that for the wood starts, the contraction that it should have done, if it's properly seasoned, it now start doing it. So you now see that the wood is,
You can't close the
deforming, you
door
can't close it properly
properly.
and all that. So those are some of the common errors that you see. So if such wood is now installed in a concrete member of the wall and
Yes.
the issue happen, then you see that it's deforming and you see some cracks.
Yes.
So that cracks is not a major crack that is affecting the building structurally,
Okay.
but it's affecting the services, some members or some fittings in the building. So it can happen with your door, it can happen with your cupboard, your wardrobe, and all that in the building.
What of the one that has to do with glass? There are some glasses that they are sliding glass. Then by the time they fix the inner part of it for the glass door to fit into it, there's a way there'll just be a crack beside it. Is this one a plastering failure or a plastering crack?
Yeah, it's more of the joint failure between the fittings of that glass,
Okay.
like the frame, and the wall that is being connected to. So that one are cracks of not fixing it properly. The joint between a member and the other one,
Yeah.
between the fittings and the other one. So, and they need to be addressed. Now, the fact that something is not a structural failure
Failure.
does not mean it's not a major issue too.
Okay.
It's just that it's not enough to really take the building down. immediately. Now, if such is happening, it needs to be properly addressed, because if those holes are happening, it can lead to leakage of water from outside the building inside.
Oh.
It can lead to inconvenience. It can lead to ants, termites, and some other things to pass through those cracks. It can harbor germs. It can harbor a lot of things. So it's also a major issue that should be addressed properly.
So aside from the natural movement, which we know as the contraction and the expansion movement, are there other natural forces that can enable cracks in a building?
Yeah, there are. There are internal and external factors that can cause it.
Okay.
Number one, for the internal, which most people do, is that when the building is not used for the purpose it's meant for.
Okay.
Okay, so when a building is designed for residential,
Yeah.
for example, and you end up using it for a warehouse, right? So maybe you have the purpose for it for residential before, and for some reasons there has to be a change in plan. You maybe you are not an importer of goods before,
Yeah.
and you are using your building for your normal house, then you now need to be an importer. So you need to talk to your professionals that build a house for you, that can this thing carry the kind of load that I want to bring into the building. For example, this space that we are now,
Yes.
the slab is only carrying this chair and some other things. There's a lot of spaces. But if it's converted to a warehouse for usage,
Okay.
everything will be filled up.
Yes.
And how heavy those things are matters to how they are being built. So if it's not built for carrying heavy loads and you change the purpose, then cracks can come up. There can be failures in the structural members because they are not designed to carry those loads.
Okay.
Right? Talking about if there is a modification,
Yeah.
maybe there's a renovation and it's not properly done in considering the structural stability of that building.
Okay.
You understand? If we want to do a modification or renovation majorly of a building, we do what we call NDT test, non-destructive test. That test is to know the current status of all the structural members of the building. So knowing the current status, knowing their strengths, we'll know if we can, if we should strengthen them for them to now be able to carry the new load that we want to impose on it. So those are some of the internal factors, right, that can affect. Now talking about external,
Okay.
thank God for Nigeria, there are no big natural disasters like
Disasters.
earthquake,
Yeah.
right? So earthquake now can take a building down,
Wow.
right? But if you look at the countries where earthquake happens, they have put a lot of technology and sciences in place that it limits the effects.
Okay.
So recently, will I say recently or towards maybe end last year, there are some earthquakes that happens and in those countries, and all their high-rise building, I mean high-rise buildings, skylight buildings, they're able to survive it.
Wow.
Yes, there's a lot of shake, there's a lot of this thing, and you know those buildings are tourist buildings that they have swimming pools at the top and all that.
Okay.
We see the waters of those pools splitting out. We see
Yeah.
the building actually shaking,
Wow.
but they are still able to stay. All right, at the end of that storm, that storm is a very earthquake is a very heavy one.
Yes.
Right, it's an earthquake, not storm, not thunderstorm, and they are able to survive it. Even
Wow.
some buildings that are twin buildings that have joints between, like a passage joint between them.
Okay.
The joints, the passage joints that you can use like a passage from this
From this building to
tower
the
to the
other.
other cracks off,
Wow.
but the building itself is able to stand. So
Wow.
those are the beauty of how engineering has advanced. So they're able to survive that.
But
So
in a case where it is not earthquake, if it is like sandstorm, sandstorm can even come from underneath the building, and then could structural engineers also still research more, or are there ways to allow buildings to survive that?
okay, everything is peculiar to areas and environment.
Yeah.
So for the kind of wind we have here,
Okay.
the wind load that is being considered in the structural design and all that are already okay for them, and they can, if the building is done properly, the highest is if the roof is not properly done, the heavy windstorm and all that can take off the roof, but it cannot crack the building structurally.
Okay.
All right, and the areas where there are big thunderstorm, earthquake, and all that. There are technologies in place to prevent it, but they are the factors that cause cracks.
Wow. Talking about the areas and environment, I want us to like dive a bit into timeline and environmental factors rather. So are there some timelines that artisans, developers should take note of? And what I mean by take note of is if a particular mixed ratio is supposed to last for 5 minutes, they don't just go for 2 minutes. If a particular place is supposed to get dried for like 15 minutes or for like 3 days, for 30 days, for 20 days, and it doesn't happen that way, can some of these things lead to the building cracks?
Yes, they can.
Okay.
In the environment we are, there is high demand for housing, and builders, contractors, developers always work with a very tight timeline.
Yeah.
So it leads to them doing some things that are not supposed to be done. Meanwhile, it's not that they cannot still achieve the speed. It's about putting the technology requires in place, right? There are some mix that, okay, if you mix it, it can cure in a short period of time, right? But did you put into considerations the chemicals and method of mixing that you're supposed to do to achieve that? If a slab is supposed to cure in 21 days and you want it to cure in 14 days, there might be some, technologies to do to that. There might be some chemicals to add to achieve that, and a future issue. But you don't put all that into consideration. Your design is saying that this lab is going to need 28 days to cure, but you want to achieve it in 21 days. You cannot just, the same method that you use to mix and place for you achieving 21 days will not be the same method, the same procedure you will follow, the same mix ratio and chemicals you will follow for you to achieve 28 days. So if your design says 28 days and you want to achieve 21 days, then you have to put in some measures to achieve 21 days. Not that you just do the same thing for 28 days to achieve 21 days.
Wow.
Right? So those are the things around it. If you want to achieve speed, then you have to put some things in place to achieve the speed and the same quality.
Okay.
But if you don't put those procedures in place, you achieve that speed, but you don't achieve that quality. And those quality failure are what leads to the cracks that we are talking about.
So still on timeline and environment. Now there are instances where we've seen clients that want to build and also regulate in the same timeline as their friend.
Okay.
So in a situation where a client's environment has to be like a rocky ground, and you know that building on a rocky ground is actually hard, building on a dampy area where there's so much water would actually take a lot of time. Now, how do you convince such a client that, oh, if we should do it the way your friend told you that it's going to go, with the timeline and everything differ, but if we should do it that way, so many things can happen, including cracks in your building, which can also lead to the building not getting up to your satisfaction. So how do you convince such a client, and how do you undo buildings like that?
Okay. Like I used to say, it's more about clarity.
Okay.
So it's about giving the client the clarity required,
Yeah.
the explanation required, the professional advice required, and try to break it down and explain why this have to be like this. So that's all that is needed. It's now left to the client to try and understand and trust the judgment of the contractor they are dealing with. So that's how we go about that. There are many different, when it comes to assembling construction materials together, there are many factors. Talking about climate, weather, and all that. For example, if you want to mix in a harsh weather, where the weather is very hot and all that, the reaction, the action on what you are doing, on the structural or the construction you are doing, is different from when you are doing it in a place where the weather is still soft, where it's not so harsh, where is, when we are building in rainy season, there are things we consider to when we are building in hot season.
Wow.
Right? So all those things matters to the longevity of your building. It matters in avoiding cracks. It matters in different factors of the building.
Okay, so I want us to just briefly talk about this season, dry season and rainy season. So you mentioned that even from the type of water that will be needed in mixing the formula. Now let's talk about the dry season. Does the dry season have any impact on the formula for the granite, cement, and everything. Maybe they will need to use in rainy season, you can use 2/3 of bottom. In dry season, you can use 1/3. And there are underlying factors to cracks in buildings.
Yes, it matters. One of the things we put into consideration during rainy season is that things don't get dry easily,
Okay.
right? Meanwhile, it helps in some cases while building. There are some structural members that I mentioned the aspect of curing the other time that
Yeah.
is not getting dehydrated easily. Water is not coming out of it easily. So in some cases, it's good for the structural member. In some cases, we have to put in some factors to manage it, right? For example, in mixing now, during the rainy season, the sand that they are bringing to you is so much wet already.
Wow.
So what you are mixing with it has to be moderate.
Okay.
Now, even if it is supplied on the site, rain is falling on it, there's a lot of moisture content in it. So using it to mix have to be, there have to be factors to be considered. Now, while mixing, the weather is soft, it helps the concrete. But what about after mixing? How does it help? All those things have to be managed, right? So those are, there are things we manage and consider when we are in rainy season to build, and there are ways we consider things when we are in sunny or hot season to build. So all these things all these factors matters in avoiding cracks and structural stability of the building.
All right. So we've spoken about the primary cause. We've spoken about impact of poor workmanship. We've gone from the natural movement to the types of cracks, and we've also identified the root cause. Now, I want us to talk about the preventive measures. What are some of these preventions that it could be clients, it could be the artisans, it could be building contractors? What are some of the building preventive measures that one can use, especially when crack is involved?
Okay, for the major structural work,
Okay.
the preventive is to build right. The
Oh,
preventive is to build to standard and recommendations.
yeah.
The preventive is to build according to building code. That's just simple. So make sure it's a professional that is handling your work, and they are doing, and those professionals are willing and have the track record of doing the right thing. So that's one aspect. When we started this session, I spoke about some three major causes of the cracks.
Of course.
So now the first one is what I said earlier, that for the structural aspect is to build right,
Yeah.
to build accordingly. Now for the wall, right? Whenever there is a crack, when a crack is being done because we want to lay a pipe and everything,
Okay.
one of the things we do is that we lay a wire mesh. It's like a soft reinforcement for that wall. So where we open the wall for service pipe, maybe electrical pipe or plumbing pipe, we apply a wire mesh before plastering it back. There will be a kind of cement mixture, then we'll put the wire mesh, then we align it. So it reinforces that place from cracking. So that, because there is majorly no other way to take pipe through your wall than breaking. So artisans need to break. But when they break, we put the wire mesh to reinforce that wall against cracks.
Yeah.
So that prevents cracks, right, from the
Yes.
wall. Now, in terms of plastering too, there are cases whereby there's a high thickness. We take gauge for the building before casting, before plastering. So when we take the gauge, some places might need higher plastering work. The thickness will be high, while some will be low, right?
Okay.
So in places where you have like above 2 cm of thickness, right, we'll add the chicken mesh or wire mesh that I say is commonly called chicken mesh. We'll apply it before we continue another layer of plastering. So that helps to reinforce the plaster,
Okay.
right? It's like a reinforcement for the plaster for it to hold well better, to avoid it from cracking.
Yeah.
Right? But there are some tiny, tiny cracks that are visible, but some are not really visible. You just see a shape of cracking on the
Okay.
wall. That one is for plastering, right?
Yeah.
That one with screeding and painting, you
It's a cover up.
do away with that one, right?
Okay.
So there are methods of reinforcing cracks that are intentionally done, that are purposely done in the wall,
Yeah.
and there are method of reinforcing plastering works. Also, like I said, the chicken mesh and all that, after you must have done your proper mixing and all that. So those are the ways of reinforcing the plastering work against crack. So I've been able to answer the three: the foundation, the structural member built right according to recommendation. For the wall, use chicken mesh to reinforce the cracks that is being done due to service pipe installation.
Yeah.
For the cracks, for the plastering, mix properly. Then after 2 cm thickness, you use your chicken mesh to also reinforce the layers. Then you are good.
All right. So what are the things that we as humans should not do to a building to avoid cracks? Because the structural engineer can do their own, and then people can also be doing some things ignorantly or subconsciously. So what are some of these things that humans should not do to their buildings?
Okay, use it for the purpose. Use the building for the purpose it's built for.
Okay.
If you want to use it for another purpose, inform your builders
Yeah.
so that there can be recommendations on what should be done. Avoid your building from leakage, right? Leakage also leads to cracks in the building.
Okay.
So when there's a lot of leakage, it starts weakening the structural member, the wall, and all that. And before you know it, cracks can come up. Avoid leakage in the building. Now, leaning on the wall, do it properly.
Yeah.
There are cases whereby you need to nail to the wall to install your maybe cabinets and all that. So it has to be done properly. So all those factors are factors that affects that should not be done for you to avoid cracks on your building.
We've come to the end of today's episode, and if you were listening well, you would know where I mentioned about weight loss and when you gain weight. So if you didn't listen, go back to the part where we spoke about the expansion and the contraction. Yes, natural movement in building. Also, on this episode, we spoke about different kind of cracks from the structural design to the plastering, and we also talked about the mixing ratio. Also, you're going to learn that it's not all the kind of water that you see out there that you use in mixing your formula, especially for the rainwater. I learned about that today. So go back and listen to it, especially for those of you that used to fast forward. Go back and listen to it. And this particular episode is still sponsored and projected by Realistic Project. I mean, they're here to educate and also inform you on how to build better and also for longevity of your building. So if you're not following Realistic Project on YouTube, on Instagram, you're not doing yourself well. So go back and follow, subscribe, and also turn on your notification buttons, because there's so much for you to learn, there's so much for you to gather, and there's so much for you to patronize. Just make your inquiries today. Mr. Adebayo Giwa, is there anything you would love to say last?
Yeah, it's for people to adhere to all this educational information we are giving them concerning their building.
Okay.
Because building is so much important. It's the shelter that covers us. It's the shelter that we seek under. So we want people to take these lessons and make them to let it impact their life, right?
Yeah.
Thank you.
All right. You've heard that. See you on the next episode.